I'm here with Senior Fellow Tero Kivinen. It's such a privilege to get to interview on camera. I heard that this is the very first time that you agreed to do this on camera for SSH, so welcome.
For anybody.
For anybody? Oh, I thought there was for SSH, for anybody. Okay, cool. So I've asked people when was the first time they used Secure Shell? But with you, this question might be a little bit tricky because I think you might have used it before it was released. Am I right?
Probably, although it was released because it was in the university. We were using it in the university. Tatu made it for university use and we started using it there, and we of course made modifications there which was needed for the university use and that kind of things, and I started using it at that point.
So the summer of 1995?
No, it was before that. Because SSH...
was released in July of 95, so was it already in the spring that you got to use it?
No, I think it was... the first version of the SSH, the one that was used in the university was done. I think it was the previous, 94, I think, exactly. I have to check, but I think this was before it was publicly released. Yes, so SSH communication didn't exist, and this was done in the university only. So it was between the Helsinki University of Technology and the different machines there.
Yeah. So Secure Shell has been used for decades now, and I know that you worked on both the first version and the second version of it, but do you see that there would be a need for the third version of Secure Shell protocol?
So that's a good question. There is that the first version was broken, so there was definitely need for second version. The second version, we did quite a lot of things, but we didn't finish all of the things that we were supposed to do. For example, the file transfer protocol was never actually standardized. It's still everybody using different versions of the different drafts from IETF. It was never published as an RFC. And actually there's an SSH maintenance working group now in IETF that will start working on that. The agent protocol is about the same, I think. There were some versions of the drafts out, but everybody's using a little bit different versions. There has been discussion in IETF to replace instead of using the standard, the normal, the crypto that is used in the SSH, replace it with Quick, which would, put it in the same, way that TLS is using, meaning it would be useful because Quick is more modern crypto stuff. But the problem there is that that only offers you the encryption layer. The thing that is really important in SSH is the authentication stuff.
Yeah, so it would be a momentous task to replace all the SSH keys that already exist in the environment.
So that's why the authentication, and actually TLS never uses it uses only this one-way authentication or opportunistic authentication. So for what I'm actually talking about in IETF, we have several crypto protocols. We have an IPsec, we have an SSH, we have a TLS, we have HIP. All of them are actually doing about the same thing. But there is two different dimensions, there are different things. There is one layer is to say, okay, which is the, opportunistic things and which is the, administrative, negotiated things. So if you want to do opportunistic connections for example, TLS, you don't need to talk to the other end, to the remote host, to be able to take a TLS connection. If I want to take a SSH connection to some remote host, that's never going to work. I need to go and talk to the admin of the remote host, ask him to, give me a username and what authentication method I'm going to be using, keys or shared secret or RSA key or something like that. So I always need to have an administrative contact with the administrator before I can actually use it. Then there is an IPsec, which is similar thing than SSH. It requires you have to, talk with the other end and set it up. You can't assume that the other end runs IPsec and you can actually just connect it. HIP was supposed to be about the same thing that TLS does but with the IPsec, meaning the opportunistic thing that you could actually just a HIP connection to whatever the other end is and it would automatically accept it. And of course there's another other layer is that whether you're doing user layer or kernel or whether you're doing TCP or IP. So HIP and IPsec are on the IP layer, usually on the kernel, and TLS and SSH are user mode and on the TCP or UDP layer. I mean, UDP is the quick, for example, TLS using UDP layer now. So this way we have these 4 different protocols that are in different, different use cases.
Yeah, use cases, and also I see it also that there's that opportunity when we have different implementations, even if they implement even same cryptographic algorithms, we distribute the risk by having slightly different ones. So you could have IPsec tunnels that have secure shell tunnels inside if you want to be really security conscious.
Yeah, there is, but of course, as long as we are using same crypto, and actually we are using same crypto protocols quite often, we are using Sigma quite often, which is the protocol to actually, for example, IKE is using Sigma. I think the TLS 1.3 is actually using Sigma, which is sign and MAC. So this is like a higher layer crypto protocol, not talking about any of the algorithms, but what you sign and how to authenticate, how to do these kind of things. And if that's broken, then all of these are broken, so it doesn't really help on that sense. But
I would say that quite often
implementation issues
are
yes.
And that tends to be, at least the old TLS stuff used to be broken most of the time because the implementation of the TLS was somehow messed up. So not so much need for the Secure Shell 3 protocol. I
don't think there's need for version 3.
Yeah.
I think we should finish the stuff that we have been waiting for 20 years now for the the file transfer and the agent stuff, and that should be enough for it. And one of the problems with SSH is the same thing that is with all of this, that it's very slowly updated. There's lots of devices that are using very old versions of those that they are never going to be updating, and sometimes it actually causes problems. Like I have had a switch that was using, it did require you have an RSA key that is over 2000 bits, but it still supported only Diffie-Hellman, that is the group 1 and the SHA-1, which means that you couldn't use an OpenSSH to connect because that didn't allow you to. Actually, it was using short, RSA keys. Yeah. So the RSA, the OpenSSH didn't allow that short RSA keys, and then the other implementations that didn't support, some of the other parameters that it was using. So I couldn't actually find any version that I could actually talk to that box without modifying the source code.
Like when we had these post-quantum cryptography algorithms introduced a few years ago. At the same time, we decided to drop SHA-1 from the places where we're not supposed to be using SHA-1 from the defaults. And we had given the customers 11 years to migrate, and we thought that surely they would have by now updated their tech. Yes, this is a safe thing to do. And we can't go and ask every single one of those customers, like, have you updated yet? And by the way, they probably wouldn't know themselves have they done it or not. But sure enough, when the PQC version went out and it was rolled into the environments, there were financial institution customers who suddenly realized that they have these old HPUX boxes in some corner of the organization using exactly the old SHA-1 Diffie-Hellman groups, and then we had to make adjustments so that they would be able to accommodate some of those older things. But it's a different thing. It takes far longer usually to migrate than what people think.
And of course, one of the problems with the SHA-1, for example, is that SHA-1 is still fine if you're using it with the HMAC.
True.
It's not fine if you're using it at the hash. So that's why, for example, Sigma, which is used sign and MAC. So it's actually macking it's generating, it's signing and, taking a MAC of the identity and signing that, which means that even if you're using SHA-1, it should be safe. But if you're using I don't actually remember if actually SSH using that version of not.
This is an excellent point, because in real life with the people who actually do the deployments, keeping track where you can and cannot use SHA-1 is so difficult that I think if you look at the most updated governmental instructions on what you're supposed to be doing on your deployments, it actually forbids SHA-1 across the board, because the chances that if you allow it for HMACs, you end up misconfiguring something and allowing it for something else where it's not supposed to be used. So they rather take this approach these days that they just categorically deny using of it so that you don't shoot yourself in the foot, so to speak.
Yeah, but that's, as I said, there's still going to be some old boxes, so that's why.
We can't get rid of
so
those.
That's why it's very important that you still have the support compiled in, so you can actually enable it without. So for example, on my end, I ended up using Telnet.
Oh, goody! Well,
because that was the only version that worked. I couldn't find any version of the SSH that I could actually. I tried, if I tried very old version of the SSH client. Then the other one that uses some feature that was not supported by that, and if I take the latest version of the OpenSSH, it didn't allow me to use, some of these other features.
You should have gone and dig out some old Texia version to get sorted.
No, that didn't work. That's what.
That didn't work either. Yes. Okay, so nothing worked.
Because I had two old versions of the Texia versions.
Okay, sounds like a dilemma, and I'm sure we're going to run into these more now that we upgrade to the post-quantum stuff going forward. Now, you worked a lot on the standardization, both in IETF and I'm not that familiar with your other thing, the email related.
IEEE. Actually, there's three groups that have been active. So IETF is the one that I have been active for longest. Then I have been also active in IEEE, mainly for the IoT, radio networks, 802.15.4 and that kind of things. And then lately I have also been, because of IKI, I have been active in this MAV, which is the mail and mail, related stuff.
Yeah. So IKI, for those of you who don't know, can you briefly?
IKI is a non-profit organization offering permanent email addresses, meaning forwarding. So my email address is same since 95.
Yeah, that's pretty impressive.
And it had been forwarded to it has been forwarded to university at one point, then it was forwarded to my office, or corporate address, and then when that didn't work any well, I forwarded to my home machine now. So it's same address, I just forward it wherever I need it.
Yeah. So you worked on various different standardization things. What is the thing that you're kind of most proud of? Like, what do you think that your legacy will be? Because it's pretty impressive, like leading the IPsec.
So when I actually joined SSH, and we had this, you have to have this kehityskeskustelu, this, and you have to have, and Tatu was talking with me with that okay, what I see in the future, and I said one of the reasons I joined SSH is that I think SSH can make a difference in the world.
Oh, that's
so
hard.
So I wanted to be there because I wanted to be part of that actually makes the changes this, that how things are transmitted over the internet. I mean, at that point it was really funny because we have some customers coming in, and when you notice that they actually use Telnet, plaintext Telnet, from our office to their US firewall, and from there to their development machines when they were looking at the source code. And you realized, okay, this is, I think they should be knowing that what the SSH is. This was our IPsec developers, but but they didn't actually use SSH at that point, and that was one of the things. Okay, we should get rid of that. And nowadays you don't see anybody using Telnet anymore at all. Actually, most of the operating systems don't.
They don't ship it.
They don't ship
Telnet,
it anymore.
Yeah.
So.
And I also heard a few years ago that FTP, like somebody broadly said that nobody uses FTP anymore, and I'm like, oh, I beg to differ. Mainframe still to this day use FTP, but then when you have these old protocols that have absolutely no security whatsoever, you can use Secure Shell or TLS to wrap that in a like encrypted tunnel and use them securely. So in IETF, what do you see the future like? Where do you think we should put effort in right now? Like what do you
So we in IETF we started an working group for SSH maintenance. It was started in like a couple of months ago, so it's a new one. And the idea there is that we have the previous, when the SSH working group, original SSH working group, was shut down, there was no place to actually do any SSH development in there. And there was some leftover draft that was never actually published as an RFCs, and now this SSH maintenance stuff is actually trying to pick up some of those and also standardize things that has been used in other, in some implementations out there. So it's trying to keep up, standardize whatever, or let's say, take those things that are out there and put them in the paper, put them in the RFC, so others can actually implement them. There's have been some implementations that you have to read the source code to actually understand what it does, because there's no documentation what it really does, and you can never actually trust the documentation to be accurate, even if if they have some kind of documentation there. And so that's one of the things that they are doing, and also the other thing is that it's doing this post-quantum algorithm stuff for SSH. And so meaning MLChem and
MLDSA.
The signatures are actually
not yet on the pipeline.
They are coming to the pipeline, but actually most of the people are interested in this kind of thing: store now and decrypt later.
Right, the harvest.
Yeah, so people are not really. I mean, any of the signature stuff is only. Any of the signature stuff in this kind of environments where we're actually doing logins or something like that. It's not important until you have a machine that can break, our authentication algorithms in real time. Mm. And for example, the RSA, it's possible to do real time encryption or breaking, because you don't need to actually do the real time calculation. You can break the RSA key, get the private key out by using post quantum algorithms, and then you can actually quantum computers, you can get the private key out, and then you can actually do this kind of authentication in the real time. But in some other cases, it's not possible to do that kind of things, and I think actually DSI is. I'm actually not sure if can you actually break it in such way. Might be, yeah. But anyway, so authentication is still you need to have a quantum computers before it really becomes important, because I mean you have to have it there if you want to hijack the connection.
Yeah. On the certificates that I think the LAMPS working group is working on.
Yeah. Certificates are different, because then you want to have if you want to have a document as a signature, or you have a firmware that has a signature that's saying this is not modified. That is of course important for a long time. But the authentication is only valid for that few seconds. I mean, it doesn't matter if somebody can fake your authentication, 10 seconds later, because you have already logged in, and he can, he needs to have it before you have it. So that's the problem. But if you store all the data and then you decrypt it later, that's actually something. The problem with SSH is that, or actually. The good thing and bad thing about SSH is that there's lots of things that are not really important in SSH connection. If you are doing just some normal cell maintenance stuff, you are just, typing in commands and running these, that information that you are transmitting over that SSH channel is not really, useful in 10 years' time. Mm. But yes, when you actually change your password over SSH channel, that information is going to be important 10 years time. So if you haven't changed it again later, so that's why it's you have to be able to you don't know whether there's an
or you use secure file transfer to get a backup, and that backup tends to have some sort of information that
backups on that, but actually remote access shell type of thing, that's usually the you are more concerned about somebody actually hijacking your connection with root shell to the machine and installing backdoor than you are actually somebody finding out that you are running, you are installing this version of the software at this point of time. Mm.
Yeah, but then quite often the problem becomes that how do you tell the difference? Like, is this important enough? So then it might be your best course of action is to just use IPsec or secure shell, regardless how sensitive do you think the thing is? Because there's also the other side of it that you might want to keep it. You might want to hide the important stuff in all of the not so important stuff.
That's actually what happens there is, if I say, if you want to, find out when you actually change your password, you probably need to store all of your SSH connections between the host and decrypt all of them, and then you might find one that is actually the important where you actually changed your password for the few, and then you have to find out that whether did you actually change it later again or not. Is it still same or so on?
So what would you tell yourself, like, if you could go back in time, like some advice for a young Tero when you started out? Like, or there?
Why should I do anything different? I did everything I did. I wanted to do anyway.
Okay, so no regrets.
No.
No. Is there some lovely story, without naming any customer names or anything like that, that you could share about maybe the early days?
There is several stories. One of the things I have been telling actually several people around is that this was actually the big financial institute, and they were having this problem with the SSH secure shell stuff, and they were saying that it doesn't matter that we can do this thing because it's we have been audited that we have to encrypt 99.5% of the stuff or something like that. So we can still have clear text data for some data. So changing password using Telnet is still okay because the password there was a problem that even if you tried to change the password failed because the password command in the Unix shell wanted to have some weird different UID set before you can actually do the password command. And that failed in over SSH connection. They say, okay, we don't have to use SSH for that. We can use SSH for everything else, and then use Telnet only to change our password, because that's less than the amount that they have to encrypt. And no, that's not the solution.
Yeah, I mean, it's such an interesting thing that you say that happened a while back, because we have had the same thing in the operation technology environments, where the argument goes that they have been tasked to find out crypto inventory of what they're using currently. And this specifically says that they're interested in cryptography. So they said that don't mind the plain text connections, because we're only tasked to find the vulnerable cryptography. Plain text is fine because at some point it has been decided that it doesn't need to be crypted or whatever. Yeah. But the logic there probably should be that looking holistically what makes sense and what needs to be secured. What kind of things do you see right now being pressing cybersecurity issues that would need to be fixed, ideally?
I think we are actually doing, as I said, that I have been more in IPsec than in SSH maintenance or anything like that. But in IPsec environment, we have already fixed most of this. We have this, post-quantum crypto algorithm framework. We don't actually have any of the algorithms yet there. But we also have the other thing. We have this. We have a way of doing post-quantum crypto or secure post-quantum crypto by adding, some shared secret into the crypto stuff. So we have been safe for that. If you want to use that for I think about 10 years ago or something like that, when the PPK first time came out. And now we are actually starting to working on this post-quantum algorithms, because the problem with post-quantum algorithms was that at that point when we started working on these, they were not ready. And there were so many of them that we didn't know which one to use. And so now we are starting to work on the actual algorithms to how to actually do this without using, this kind of shared secret. Because, I mean, shared secret, if you just share shared secret, use it as a key, as a, or mix it into the actual, transport key, that's actually secure against post-quantum computers, because if you don't transfer the key at all, the post-quantum computers or quantum computers can't break it.
Yeah. Pre-shared also implies that it has to be shared before you do things. So it kind of works in the situations where you are in complete control of your own
I mean, that's, as I said, both SSH and IPsec are in this kind of environment, so you don't expect to be able to connect to random machine with SSH or IPsec without first talking to the admin of the other end. So you have to set up the, this kind of authorization,
But these days, it's in Secure Shell, we can do the authorization on demand, on the fly. Like that's one of the use cases of PrivX, our privileged access management system, so that with externals, you're able to connect through that and get.
But you're still using just some backend, which already has the so.
Yeah, so there's certificate-based authentication.
But it means that you have already still done the first step.
But for that particular real user or the automated system, the credentials are created. Yeah.
But if I, as a random person, tries to log into there and say that now Kivinen wants to log in,
what would happen there is like a work a step process where you would request for the access, and then
Yeah.
somebody would have to go in and actually give you that
And
access.
they would probably, who is this? And they would start finding out that I would probably need to call or or ask somebody
Yeah,
to call.
I would say that
and
something has already gone wrong if you've been able to even submit the request to it. Like there needs to be that sort of first gate in front. Yeah. So, is there something else you'd like to share, or?
No, I don't think.
Yeah, you're good. Okay. Thank you so much, Tero. This was lovely.